All right, so we're going to custom design a counter. It's going to be synchronous. And we are going to make it with SSI, so with JK flip-flops. Okay. We're going to limit it to a 3-bit counter, not to be too big and too complicated. But the beautiful thing about synchronous counters is that it really can go all over the place. You know, traditionally counters, we go up counters, down counters. Here we can really go up, down, and we are not limited by anything. So Rini, since you're on camera with me, would you care to give me a counter? So we can start wherever you want, and we can go in any direction, up or down, as you choose. You're muted, so.
3.
Okay, we can start at 3. Then what are we going to have after the 3?
Say 14.
What did you say?
3-bit counter will be say 7. Okay. Say 7.
7. Okay. Then what?
And then, oh, we wanted to skip it, right? So
if you want to skip, yeah, we can. We don't even have to have 8 numbers if you don't want to have 8 numbers. 3 bits allows us to have 8 numbers, but here we can just make it with 6 numbers if you prefer.
So we can maybe now, okay, we can do 3, 5, and then 3 to 5, and then skip to 7.
No, you already said we go from 3 to 7. What are we going to go next after? After the 7, what number do you want?
0.
Okay. After that, what do you want?
2.
Okay. After that, what do you want?
4.
4. Okay. And we can stop here if you want. You know, we can go back to 3 now if you want, or we can choose another number. It doesn't matter. What do you want after the 4?
5.
5. Okay.
7.
You want to go back to 7? Okay.
And then it can continue, I guess.
All right. And then we're going to go back to the 3 like this. Okay. Okay. Very good. No problem. So what we're going to do now is we're going to grab that beautiful chart from before. So, oops, this one right here. This table is what we need to design our counter. So I'm going to copy this, and I'm going to place it right here. We need this table to design our counter. So we're going to have 3 flip-flops. So we're going to have flip-flop A, flip-flop B, flip-flop C. The A is going to be my most significant bit. My C is going to be my least significant bit. Okay. And then I'm going to have my next output of the flip-flop A, my next output of the flip-flop B, and my next output of the flip-flop C. Since we're dealing with JK flip-flops, that means that for each one of those flip-flops, I need 2 inputs, JA and KA, JB and KB for the flip-flop B, and JC and KC for the flip-flop C. Okay, so we're going to have a table right here. I'm going to take a few seconds here for my setup to be ready. Go. Right. And let's do this right here. It's going to be my JA and KA, my JB and KB, like this. All right. So for the table now, we're going to start at 0, 0, 0. You're going to have 0, 0, 1. I'm always going to start with this truth table. Okay, the pattern, I'm not going to mess around with it and change it. I'm just going to leave it the same all the time. Okay. I'm going to also write the decimal value of those numbers. So 0, 1, 2, 3, 4, 5, 6, 7. All right. So let's look now, Rini, at what you chose above. Okay. You chose that if the number displayed is 0, the next one is going to be a 2. So I'm going to put a 2 right here for the next number. Okay. Below it, we have the number 1. Okay, we have the number 1 right here, but we didn't choose the number 1 up here. That means that this condition right here, we're going to avoid. That means that really, we don't care what's going to be after the 1, because we will never be at 1. Okay. If you look above, after the number 2 right here, we're supposed to display the number 4. So I'm going to put 4 right here. Okay. After the number 3.
Oh,
Yes.
okay, so we are not considering the 3 anymore?
Yes, after the 3, we're going to have it. We are the 3 right here. After the 3, we're going to have the number 7.
Okay.
Right.
Now, yeah. So after the 2.
After the 3, we're going to have the, but don't take notes, please. Just follow with me. Okay, because there is a problem in here that we will have to, that's going to make our choice of designs have to change. Okay, so we have a 3 right here. After the 3, we're going to have a 7. Okay, so what I'm going to write here is I'm going to write 7. Then I'm going to go down to the next one. We have a 4 right here. If I look at the choice we made, after the 4, we're supposed to have a 5. So I'm going to put a 5 right here. Okay. Then we are at 5. After the 5, we're supposed to have a 7 right here. Okay, so I'm going to put a 7. Next, we're going to have a 6, but we didn't choose the number 6 in here. So after the 6, basically, we can have anything that we want. So I'm going to put a don't care right here. And the last row, we have a 7 right here. And here is the issue. If I look at this 7, the number after that will be a 0. If I look at this 7, the number will be a 3. I cannot have 2 different numbers. The logic says that if I have 7, I must have one number after. And so this design here is not going to work if we build this using a counter. There are other ways of making it work, but not if we make it as a counter. And so as such, this is not going to be possible. So what I'm going to be doing here is we're going to change it a little bit. And so instead of going from 5 to 7 on the right, we're just going to go from 5 to 3 on the right. Okay, so I'm just going to decide, we're going to change the counter a little bit like this. Okay, so what does that mean? Well, that means that up here, I'm going to have to remove this 7, and I'm going to write a 3 instead. After the 5, we get a 3. And after the 7, we're going to get a 0. Okay, and this is going to work just fine for the thing. So what do I do now? Well, now we want to display the number 2. Number 2 is going to be 0, 1, 0. The don't care, so we're going to have don't cares right here. 4 is going to be 1, 0, 0. 7 is going to be 1, 1, 1. 5 is going to be 1, 0, 1. 3 will be 0, 1, 1. The don't care will be don't care, and the 0 will be 0, 0, 0. Do you understand how I put those zeros and don't cares right here.
I think I kind of forgot what we said earlier.
So if I looked for those three numbers, I look this number. I want a 2,
Okay.
so I'm going to have 0, 1, 0. I want a 4, so it's going to be 0, 1, 0, 0.
Okay,
I want a 5, like this. Okay. Now, for the JA and KA, what I'm going to do is I'm going to look at this chart right here, and I'm going to color code my things here so that it's easier to understand. And so if I go from 0 to 0, I know that from 0 to 0, it's going to be a 0, don't care. The next one will be how to go from a 0 to a don't care. 0 to don't care, it's don't care, don't care. The next one will be going from a 0 to a 1. 0 to a 1, if I look at the chart above, it's going to be 1, don't care. And again, 1, don't care for the one just below this. Then we're going to go from 1 to 1. When we go from 1 to 1, it's going to be don't care 0. Then we're going to go from a 1 to a 0. It's going to be don't care 1. Then we're going to go from a 1 to a don't care. 1 to don't care is going to be don't care, don't care. And to go from a 1, sorry, I need my highlighter here, not my pencil. From a 1 to a 0, it's going to be my don't care 1. And I'm going to repeat that process with
JB, KB.
With JB and KB, absolutely. So we're going to go from 0 to 1. 0 to 1 is going to be 1, don't care. This one is going to be don't care, don't care. This one is going to be don't care, don't care. Huh? Because we know we go from 0 to don't care. We're going to go to from 1 to don't care like this. So I can see that. And then I can start looking for patterns. So maybe 1 to 0, I have a right here. And 1 to 0, I have in the last row as well. So 1 to 0 is don't care 1. So I'm going to have a don't care 1 right here, and I'm going to have a don't care 1 right here. Then I'm going to go from 1 to 1 right here. Okay. And to go from 1 to 1 is going to be don't care 0. Then this one is going to go from 0 to 0. 0 to 0 is 0, don't care. Oops. 0, don't care. And the last one, we go from a 0 to a 1, which is a 1, don't care. But I just take my time, you know, be organized, write your things. And since it's a little tedious, a little long, but it's fairly straightforward. So what do we get now for C? So I see we go from 0 to 0 right here. We go from 0 to 0 right here. And that's about it for the 0 to 0. So it's going to give me my 0 don't care and my 0 don't care. Above, I'm going to have that don't care and don't care situation here, because I have a don't care and I have a don't care like this. Then what else do we have? We have from 1 to 1, from 1 to 1.
That's
from 1 to 1, it's going to be don't care 0. And then we have 0 to 1 right here. If I look at the table, 0 to 1, it's going to be 1 don't care. And the last one, we go from a 1 to a 0, which is a don't care 1. Okay. So we have our truth table. Now we need to do our K mapping. So for the K map, we're going to create our K maps. As you know, I like my horizontal K maps, so I'm going to set them up like this. And I'm going to need 6 of them. So let's create 6 of them. Here you go. 1, copy, paste right here. Okay, so let's do JA and KA first. So I'm going to go with my blue. This is going to be my JA. This is going to be my KA. So J, what do we have? We have 0, don't care, 1, 1, don't care, don't care, don't care, don't care. My K would be don't care, don't care, don't care, don't care, 0, 1, don't care, don't care. So what would be the best grouping right here to take care of everything? Well, wait, did I make a mistake here? Yes, I made a mistake.
Yeah.
My 7 is supposed to be a 1 right here. That's supposed to be a 1. All right, so what grouping can I make? Well, on the left for JA, I think that this
1, 1.
probably would be my best grouping.
Okay.
And for this one, this probably would be my best grouping. Would you agree?
Mm-hmm.
All right, so I'm going to write it down here. JA will be therefore, it's going to be my A naught B. Okay, and my KA will be my KA will be my A naught B naught C or A naught B C. So it's going to be my A naught C. All right, done.
KA. Will it not be just C for KA?
Wait a second. You are, you're right. You're right. Actually, yes, you're absolutely right. It's just good. And for JA as well, I made a mistake for both of them. I didn't consider the don't care. I just considered the ones. So it's going to be for JA, it's just going to be B. You're correct. Thank you. And for KA, we are going to have C. Thank you so much.
We could have taken like just the 1 and the 1 also, right? But then again, it's going to be a bigger like.
You are absolutely correct. Yes. Okay. So let's now do JB and KB. So this will be JB, this will be KB. So JB, what do we have? We have 1, don't care, don't care, don't care. And then 0, 1, don't care, don't care. And for this one, we're going to have don't care, 0, 1, and don't care, 1, don't care. All right. So let's do the grouping. I think that our grouping would be best for JB. Oh my goodness. We're going to have this one right here for this big group of 4. And the other one, we can have this group of 4. And for this one for KB, we're going to have this big group right here, or this group right here that wraps around. That means that JB will be A naught or C, and KB will be A or C naught. All right, and now let's do JC and KC. So JC will be 0, don't care, 0, don't care. So 0, don't care, 0, don't care. And then 1, don't care, don't care, don't care. And the KC will be don't care, 0, don't care. And don't care, 0, 1, don't care. So for JC, I think that this one will be most appropriate. And for KC, we're going to have to group those two like that. Okay. Which means that JC is just going to be A, and KC is going to be equal to our
AB
A and B. Just AB. Okay.
So would we use this for MSI?
No.
No,
this is just for SSI designs. Okay. So now, what do we do with all of this? Well, now you would go to multi-sim, but here I'm just going to do a little sketch. Okay. So we would have our first JK flip-flop like this. It's supposed to be a rectangle, so I'm going to make it again. Okay. So that's going to be our clock signal. That's going to be our J. This is going to be our K. It's going to have our Q. That's going to be a Q naught. We're going to have our preset and clear like this. And we are going to have, since it's a 3-bit counter, we are going to have 3 of them. So I'm going to copy and paste. Go. And we're going to have 3 of them. We are going to have 1 clock and 1 clock only. So I'm going to have this little clock signal right here. We're going to ground it. This is going to be the plus, and it's going to be connecting right here to all the flip-flop at the same time. This is what makes it a synchronous counter. The clock goes to all 3 flip-flops like this. Now, in the design of this example, we see that you mentioned that you wanted the count to start at 3 right here. So what I'm going to do is I'm going to force it to start at 3. Okay. So 3 in decimal, as you know, is 0, 1, 1 in binary. And if you recall, we said that this was going to be our most significant bit. This was going to be our middle bit, and this was going to be our least significant bit. That means that I need to force the first flip-flop to be equal to 0 and the other 2 to be equal to 1 to start the count at 3. So I'm going to start with a little SPDT switch right here. This is going to be grounded. And this is going to be powered. And that switch is going to be our count switch. So if it's connected to VCC, it's going to count. If it's connected to ground, it's going to stop. So it's going to be our count switch. And since I want it to be starting at 0, 1, 1, this is going to be starting at 0 right here. And we're going to go to 1, 1, like that. All the other presets and clear, I'm going to connect them to VCC. So I'm going to have another VCC right here, connected like that. Another VCC, connected like this, and another VCC connected like this. Okay. Of course, I'm going to have a 7-segment display, or I can have the fake one with the X display like this. And the most significant bit is going to be grounded, and the others are going to be connected correctly. So this Q, it's always Q, huh? Is connected to this one. Then the Q for B is going to be connected to the next one. And then the Q for C is going to be connected to the one on the right like this. And so what we need then is we just need to deal with JC and KC. Okay, C, sorry. We need to deal with JB and KB. And we need to deal with JA and KA. So as you can see, JA is connected to B. Okay, that's this one right here. JA is connected to B. So B is connected to JA. So I'm going to have this one right here. There you go. JA is connected to B and KA is connected to C. So KA, I don't want it to be too messy, so I'm going to go below my graph. Right here, it's going to be connected to C. There you go, done. Flip-flop A is connected. Flip-flop B is A naught or C. That means I need an OR gate. Okay, so I'm going to have for JB, I'm going to have a little OR gate right here. And for KB, I see a little OR gate too. So I'm going like that. Okay, and the two inputs of my OR gate for JB is going to be A naught or C. So we're going to go A naught. That's A naught or C, which is my purple one. So I'm going to go back up here. And I'm going to go connect it to C right here. And for KB, it's going to be A or C naught. So A is going to be this one. So A or C naught. C naught is going to be down there. There you go. And for the flip-flop C, JC is connected to A. So my A is up here. So I'm just going to connect it to A right here for JC. And my KC is A and B. That means I need to have a little AND gate. It's going to be A and B. So A is the same signal that I have right here. And my B is the signal that I have right here. And if you multisim this, then it should start counting the way we design. Again, it's going to go 3, then 7, then 0, then 2, then 4, then 5, and then goes back to 3. Okay. Do you have any questions for me at this point?
No.
Okay.
I'm just thinking, okay, how can probably I don't need to apply much of this in the 60 seconds timer because we already did the counter for.
Yes, we don't. This is not going to be useful for the 60-second timer because we already designed a correct, regular, simple counter back then.